Here we have a concept of factoring. So it's going to start out kind of like the distributive property, but in reverse. So think about undistributing. If I look at this first expression, try to think about what is the greatest common factor. Like what's something that I can factor out from both terms. So for the numbers, 18 and 27 are both divisible by 9. So 9 is a common factor. And then what is the greatest common factor of the x's? Well, start like this. Do they both have an x? Yes. Do they both have x squared? Yeah, right? Because there's x to the third and x to the fourth. So they got x squared. Do they both have x cubed? Yep. 3, 4. Yep. Do they both have x to the fourth? No, they don't, right? One of them does, the other one doesn't. So the greatest one they had in common was x cubed. And then you think about what's left over. So if you have 27 and factor out a 9, that leaves you with a 3. If you had x to the fourth and you factor out x cubed, well, you still had 1x left over. And here you would have minus, well, you factored out 9x cubed, so you'd have a 2 left over, and you factored out all the x's, so that would be complete. Let's try another one here. So number-wise, I'm thinking what's a number that I can factor out of 30, 45, and 90. I'm thinking the number would be 15. Because 15 is the biggest number that goes into all three of those. 15 times 2 is 30. 15 times 3 is 45. 15 times 6 would be 90. So 15 is the one. All right, so what about for the x's? Do they all have an x? Yep, they sure do. Do they all three have an x squared? No, that middle one does not. So just an x can be factored out. And for the y's, it looks like they all have a y. And that would be it, right? Because the other one has a y squared, but the other two don't. So 15xy is what we factor out. So that would be, remember, 30 divided by 15 is 2. Now you factored out one of the x's from the x squared, so you'd still have an x left over. You had a y, but you factored it out, so it's gone. Then the next one, minus, let's see, 15 went into 45 3 times, and you factored out an x and a y. So those both came out from that middle term. The xy got factored out, so you're just left with the minus 3. Then the last one would be 6. Well, let's check carefully. You have x cubed, but you factored one of those x's out, so that drops down to an x squared. You had y squared, but you factored out one of those y's, so you still have a y left over. Okay. So same idea on this next one. It's just that the thing they have in common is actually a whole expression in parentheses. Okay, so they both have the x plus y. So imagine that whole thing being undistributed back out. So it would be the quantity x plus y, right? That is the whole expression that's common to both terms. So what's left over in each term? Well, you have the 4x and the minus 3. Those are the only two parts left over from each term. So that one looks a little funny at first, but you're just treating that x plus y as a whole quantity that's coming out grouped together in parentheses. And what's left over? Oh, just the 4x and the minus 3. All right. So these next two examples are going to be kind of based on that same thing, this factoring by grouping. So we're going to kind of see a group of things that have something in common and then kind of be able to factor a second time. So for the first part, the 5x plus 10, let's just look at those two. And that one you can factor out a 5 and an x from the first two terms. And that would leave you with an x plus 2. So just from those first two terms, when you factor out 5x, you're left with x plus 2. Now in the second two term, or the third and fourth terms, the second pair of terms, there you have a 7 that can factor out. So I need a plus 7 times x plus 2. Okay, so I kind of factored the two groups separately, but look at what resulted from there. You have an x plus 2 that shows up in both of those left over. So that's kind of like that last example. I'm going to factor out an x plus 2, and then you're left with the 5x plus 7. So that would factor it more completely using two steps. One last example, kind of the same thing here. Look at the first two terms and the second two terms. So the first ones, it looks like you can factor out a 2x squared. And then you're left with 2x minus 1. And let's see. This next part's a little funny because of the signs. Like if I just factor out the 4 and the y, watch what would happen. If I do plus 4y, then you're left with negative 2x plus 1. And you see how that's not quite the same as that, right? Not quite the same. So how could I have done that differently? Well, look. It's just the signs are opposite. Here you have a positive 2x. Here you have a negative 2x. Minus 1, plus 1. So let's redo that second factoring where instead of just factoring out positive 4, let's do a negative 4 so we can factor the negative. So the first one we did fine, no problem. I'm going to leave that. But this time I'm going to factor out negative 4y. So if you factor out negative 4y from negative 8, you're left with a positive 2x. And when you factor out 4y, you factor out a negative, well, you're actually going to be left with a negative 1, because if you think about redistributing, the negative times the negative does give you the positive. So you may even think of that negative 8xy as minus negative 4y, and then you can kind of see both of those negatives show up. And that result now is more compatible. They've got the 2x minus 1 in both terms. So that would be 2x minus 1, and then you're left with 2x squared minus 4y. And there you have it.